Hello, everyone. This is Night Sky Jeff. It's been a while. I believe the last video I posted said I was in the process of moving to a new house, and I probably wouldn't put any content up until July or August, and it is now November. I recently turned 40, and I have to say, I don't have much interest in pursuing these flat Earth videos too much longer. I think I'd much rather post videos about actual science, actual physics, actual astronomy. So maybe I'll end up doing that. Who knows? But I do want to make a couple videos about Kyle Adams, who's been continuing to pump out some videos, most recently about Einstein and Newton and gravity. So I have a short video for you today based on just a couple minutes of content from a September 30th video of Kyle's entitled Einstein's Failure 2, Show Me the Math. Now, between the time that I started thinking of doing this video and now, he's unlisted this video, but it's still up there. So we're going to go through it, just a little bit of it, to explain not Einstein's failure, but Kyle's failure. In the first minute of this video, Kyle gives his own summary of Newtonian gravity versus Einstein's equivalence principle. We're going to start at 1 minute and 5 seconds, and I think we're just going to cover about a minute's worth of content. So let's listen to a bit of Kyle's remarks.
While both the ground and the apple come closer together in both scenarios have very different consequences. Now let's take a look at the math. As we know, Newton's second law of motion is force equals mass times acceleration. So when Newton drops an apple, you can take the mass of the apple and times it by its acceleration, and that will tell you how much force it will have when it hits the ground.
Okay. Kyle is right that force equals mass times acceleration, but he's wrong about what that equation means. F is not the force the apple will have when it hits the ground, but rather the force necessary to accelerate the apple at 9.8 meters per second per second. What Kyle is describing, the force that the apple has when it hits the ground, he might be meaning the energy it has when it hits the ground. Potential energy equaling mass times acceleration times height. That's the equation for potential energy of an object of mass m, dropped from a height of h and subject to an acceleration a, in this case a equals g. So potential energy equals mass times gravity times height. That's the energy the apple would have when it hits the ground from a height of h. F equals ma is not that equation.
Now let's flip that around in Einstein's perspective. If the ground is rising up to hit the apple, you take the mass of the entire Earth and times it by its acceleration, and that will tell you how much force the Earth will have when it hits the apple.
Okay, so Kyle makes the same mistake here. This is not the force the Earth has when it hits the apple. It's the force necessary to accelerate the Earth at 9.8 meters per second per second. And obviously, the force it takes to accelerate an apple at 9.8 meters per second is a lot less than the force it takes to accelerate the entire Earth at 9.8 meters per second per second.
Since the Earth has way more mass, the Earth will hit the apple with way more force. Herein, Newton's force and Einstein's force do not equate whatsoever.
Okay, neither of these equations has anything to do with the force of impact between the Earth and the apple. But more to the point, Einstein's equivalence principle does not state that the force necessary to accelerate an apple at 9.8 meters per second and the force necessary to accelerate the Earth at 9.8 meters per second are the same. No, Einstein's equivalence principle is that the inertial mass and gravitational mass are equivalent because acceleration in a non-inertial frame of reference is equivalent to acceleration due to a gravitational field. To put it another way, the weight that the apple experiences on Earth due to gravity is identical to the weight the apple would experience if it were being accelerated upward by the Earth's surface at 9.8 meters per second. That is the equivalence. In fact, the weight that the apple experiences on Earth due to gravity is identical to the weight that the apple would experience if it were being accelerated by any object at 9.8 meters per second. That is the equivalence principle. Kyle's video does not seem to understand what the equivalence principle actually states. So that's all this video is. This is part one of a short series of videos based on Kyle's videos about Einstein and acceleration and gravity. Thank you for watching. I don't really care if you like and subscribe. I don't care if you hit the notification bell. I don't get money from these. This is not at all a source of income for me. I just make these videos because I feel like it. Have a good day.